We're now going to look at the situation of bivariate data. In other words, you have two sets of data and you want to see if there's a relationship between those. So we go to Excel and I've got some project results and test results for students. So just go and make a copy of that. Come back here to GeoGebra, go into the spreadsheet view and then just paste it. And then you select both of these. And we're not going to choose one variable this time, we're going to choose two variables initially. So we're interested to see, is there a link between the project result and test result? So we want to get a correlation coefficient for that. So we don't want to actually include the title, so use the header as the title, that's good. Hit analyze. So we now have a graph of that. So each dot represents a combination of the test and the project. You can figure out, well, you could create a line of regression, or you could get a quadratic equation of regression, whatever you think. And if you have a look at the statistics for this, then show statistics. Have a look at the R value. You see that it's about 70%, so it's reasonably strong, but not good, not great anyway. So that's one way of looking at this information. You can also come in here and, well, that's not particularly useful. So you can alter various aspects of the graph if you wanted to. Again, you can take this and copy it so to the clipboard, and straight off we just go and add that to where we were previously in this document, so we've got that document there for us. Or we could go and instead copy it to the graphics view, and then in the graphics view we could come in here and say go and put in our title. So you come to text box and up here just put in some sort of heading like investigation of project test relationship, something like that. So yeah, you could. It's quite useful in this view to be able to do this type of thing. So hit OK, and you've got that, and you can then go and make that larger. Sorry, make it, so go and make it bold. So make it bold, make it larger. You've got a heading for it, so you could label anything you want here, and then you could go and export it from here essentially in the end. Okay, an alternative approach to this is that, let's see if I just do Control A, no. I'm just going to go and delete all of this that's come across, and delete. Alright, something you could do instead would be to make a point, just do it manually here. So I want this to be a formula. This is just like Excel really. You could say I want that to be my X value and I want that to be my Y value. So that gives me a coordinate, and then if I copy those down, so let's see, stop there. So each of them then appears on the screen. Alright, now a bit of a pain that you've got a label for each of those, so I can highlight this column and then right click and go into the object properties and let's see, don't show a label. Alright, so that's better. Alright, so we have all of those points there, and what we can do now is we can actually manually go and move those around, so we get a little bit more control over it. So it's just an alternative way of doing it. And if I take all of these and put them in a list, so create a, I think this is the one, I'll just check, a list L1, and then put in a command, I think it's fitline is it, so fitline L_1, L1, alright, so it goes and puts in that line, and then I can go and manually move these points around and see what effect it actually has to that line of best fit, and we can see the equation of the line of best fit just there as well. So that's quite useful. Anyway, let's undo all of this, and I'll get rid of this, and we'll have a look at another approach now. Maybe we just wanted to see a comparison of the results overall for projects and test. I can highlight both of these, and this time instead we're going to do a multiple variable analysis. So this is quite interesting, quite a useful approach, and I don't know where that's got to. Take 2. Okay, so I better stop there. Function F, sorry.